Alrighty, thank you, Mario. Thank you so much for that generous intro. Again, my name is Daniel Azir, and just to reiterate a housekeeping note that Mario mentioned, so we have a chat box that you'll see in the Zoom interface. It's probably going to be either at the top or bottom of your screen. I both welcome and invite and appreciate questions coming in, and we'll actually try to answer those in series as they come through. But in case we don't have time, we'll leave plenty of time for the end. I must acknowledge anonymous attendee came in super hot this morning with a comment in the chat box. Who's feeling pumped, ready for the seminar? Thank you so much, anonymous attendee. I am pumped and ready for the seminar. So thank you very much for that. And again, encourage questions through that chat box. So what we wanted to cover today, and if you've been part of the broader Markforged ecosystem for a while, you might recognize my face and voice in a capacity where I've been trying to persuade you to examine our technology in terms of really the cost and supply chain benefits associated with transitioning to an additive manufacturing strategy. Today's going to be a little bit of a change of pace where I think we're going to talk a little bit at a broader level, a little bit more of a 30,000-foot view in terms of how our choices, both as individuals and organizations, impact the environment. So I'm going to start off by just doing a little bit of a level set, and I'm seeing Nicholas Bollinger also pumped, so thank you, Nicholas. So we're going to talk a little bit about a level set of sort of the origins of climate change and what some of the negative consequences are, which the scientific community has largely come to a consensus on. And then we'll talk about a couple different avenues we can take as both individuals and organizations to activate change in a way that's going to result in mitigating some of these negative impacts. We'll then get kind of into the nitty-gritty in terms of numbers. So people largely think about the impact of the environment in terms of carbon emissions. So we'll be talking about how conventional supply chains contribute to carbon emissions and how additive can potentially help. And then we'll get into what I think of as sort of how Markforged fits into this whole picture, which is largely solving the broadest scope of problems across a fully digitized supply chain. And again, I'm attempting to leave a bunch of time for Q&A. I see there's already a lot of enthusiasm and activity in the chat box, so I will say I remain optimistic that we'll be able to get to most, if not all, questions. So with that, I'm going to get started. So this might be a little bit of a blast from the past, and in fact activate a little bit of nostalgia from high school, thinking about this tool, the carbon cycle, to think about how gases are exchanged in the atmosphere. So I don't want to be too pedantic, but I do want to level set on sort of how we got to the place we are today. So predating human existence and human impact to the environment, the way gases were exchanged in the atmosphere. So starting with animals, and really it's a cycle, so you can start anywhere, but let's start with animals and talk about, through our basic respiratory process, we exchange carbon dioxide for oxygen, just in the way we breathe. And that's just sort of a natural process. And then worth noting, when animals die, they decay, and those dead organisms get buried and either underground or in the ocean. And over millions and millions of years, that biological waste largely gets formed into carbon. And today we extract it as what we call fossil fuels today. So the sort of next part of this cycle is through roots. Plants actually uptake some of this carbon in what we call terrestrial carbon through their roots in a process known as root respiration. And then more notably, the way trees exchange gases with the atmosphere in a process called photosynthesis, they'll take sunlight and that carbon dioxide that's resident in the atmosphere and exchange that for oxygen. So predating human existence, this lived in a nice little balance where the amount of carbon emitted through animal respiration was wholly offset by a series of carbon sinks being things like trees and oceans. So this sort of largely stayed in balance over a long period of time. Now enter the Industrial Revolution, where we realized, hey, this this organic waste that's really rich in carbon is also super dense in terms of energy. And when we burn it, we can get a lot of energetic potential out of that. The byproduct, of course, is more atmospheric carbon, which threw this whole balance out of whack. Now, during my lifetime and when I was growing up in the 90s, the extent to which this carbon imbalance and the negative impacts of it were the topic of vigorous scientific debate. That is no longer the case. Today, the scientific community agrees that this is pretty much all our fault, and the negative impacts are potentially catastrophic to our way of life and our civilization. So I'm going to go ahead and transition into a quick overview of what those negative impacts look like. So starting with the destruction of ecosystems, if you've seen a recent animal documentary, the melting of the ice caps is a phenomenon that was likely covered. And this is not only destroying super fragile ecosystems, it's also contributing to the overall rise in sea level, which is then causing things like coastal flooding, which is reducing the total amount of space that humans can actually inhabit. And as a secondary byproduct of that, we're seeing this rate of extinction of species that's unprecedented in terms of our sort of planetary ecosystem. And on top of that, we're seeing these super extreme weather patterns. These 1 in every 500-year storms are now happening twice annually. On top of that, where I live in California, we're seeing things like extreme droughts causing decreased crop yields. These high storm frequencies causing this terrible loss of life and property. And as the overall global temperature changes, we're not only seeing the extinction of important species, as I mentioned earlier, in terms of the destruction of ecosystems, we're also seeing this change in environmental ambient conditions, giving rise to potentially harmful species. So part of what makes the so-called novel coronavirus so novel is its ability to survive in the winter months that typically eradicated, or in the summer months rather, that typically saw the eradication of major diseases. And all of this combines to threaten our very way of life. So when I talk about decreased crop yields, this is actually causing an overall decrease in the Earth's ability to support human life. And the decrease in habitable land is causing, over a long period of time, causing people to have to move from places where they used to be able to grow crops to places that are quickly and immediately becoming overcrowded. And on top of that, it's worth mentioning that in the U.S., the Department of Defense treats climate change as a threat multiplier, meaning anytime any of these categories gets worse, so more melting ice caps, higher rising sea levels, more storms, more fires, more drought, all of those impacts work to intensify the downstream impacts of what's happening. So when last year, when those fires ravaged the Amazon and in Australia, that's reducing the total number of the total amount of plant life, which in turn is reducing the total amount of carbon sink in the atmosphere, which is causing a further rise in atmospheric carbon levels. So the takeaway here is this problem is really, really severe, and should really be treated as an existential threat to our way of life. And it's really sort of an auspicious moment to take this and look at it as an opportunity to mobilize. And while the scientific community agrees, there's really no way to fully contain and put this genie back in the bottle. The negative impacts are sort of already here to stay in some ways. There's some really deliberate actions we can take as both individuals, organizations, and as a society to help contain further damage to some of these fragile ecosystems and, in fact, our way of life. So some of the mainstream personal choices that we all may have heard of in terms of our ability to reduce our carbon impact as individuals, we could take actions like flying less, switching to an electric vehicle, trying to reduce, reuse, recycle. And I was actually really bummed out to find that the best way I could reduce my carbon impact is reducing my meat consumption, specifically steak. I was probably eating steak like 6 times a week before I found that out, and now I've pretty much wholly cut that out of my diet. So that's something I remain a little bit bummed out about, but I think it's a worthwhile compromise. Um, but the reality is, on a personal level, when I say that we have the ability as individuals to change our overall carbon footprint to the tune of 8 tons, that plays into a landscape that has a much larger magnitude and scale. Um, so I'll actually talk about and enumerate some examples of conventional manufacturing supply chains. Um, but as a reasonable sized manufacturing business, when we look at the choices we make as businesses, those choices can have a far greater impact. So remember, I said 8 tons of carbon emissions is sort of what's at stake on an annual basis for these personal choices. In the case of these group choices or organizational choices, we have the opportunity to move more than 40,000 tons of carbon emissions out of our environment. And this is through a combination of green initiatives, like just reducing waste, but also things like digital transformation. So think about going from postage to fax to email. That change and the digitization of that process leads to significant downstream impacts in terms of our ability to reduce our footprint. Other means of reducing our carbon footprint include consolidating logistics and reducing waste. And really putting the pressure on our customers and our vendors in terms of who we transact with to make green choices, because ultimately the customer is always right, and if you're the customer, your suppliers and vendors are going to listen. Now to zoom this out further, when a bunch of individuals gain consensus on this and form a group, and a bunch of groups form a consensus and make decisions as a society, the impact can be tremendous. And this is really the level of mobilization that's needed in order to make a meaningful change in terms of our footprint in the environment today. So that's to say, when we as a huge bundle of organizations mutually agree that policy changes, renewable energy infrastructure, paying for what we emit in the form of a carbon tax or a carbon credit, and ultimately keeping fossil fuels in the ground, we mutually decide that's a priority. That's really going to be a moment in time where we can point to something as a policy that's dedicated toward reducing our overall impact and that overall imbalance in atmospheric carbon levels. So that's sort of, at least from my perspective, the state of the state of sort of how we interact with the environment and the choices we can make to reduce our overall impact. I'll again acknowledge that there's plenty of time to acknowledge questions. So if you do have questions, I invite you to pump those through the chat box. In the absence of those questions, I'm actually going to move on to talk at a more granular level about manufacturing supply chains. So if you're in manufacturing, and I take it if you're on a 3D printing webinar, you're probably involved in manufacturing in some way, shape, or form. This story is probably not unfamiliar to you. So oftentimes when we set out to plan a manufacturing program, we get all of our demand forecasting in place. We get the whole bill of materials. We order the long lead time items, and we've got all of our spreadsheets and Gantt charts that tell us exactly what we need, when, where, and how. But the reality of the world today is it's dynamic, and there's a bunch of unpredictable things that happen. And in response to unpredictable things like manufacturing emergencies, defects, lemons, we often take these really high calorie efforts to go and do a quick and expedient repair in order to retain and maintain a healthy customer relationship. So an example of this would be, if I'm say an auto manufacturer, and I have a problem with a component that's failing on a car in early life. I would actually, in a centralized manufacturing hub, go manufacture the solution to that defect, and then ship it to regional hubs where it's then overnighted to 500 plus discrete locations where regional couriers end up delivering the parts to the point of need. And in that period of time, I've racked up 14 tons of carbon emissions per part. So that's so for every part, we're looking at about double the carbon emissions that we've identified as the opportunity for individuals to reduce over the course of a year. And this is just one manufacturing emergency or one manufacturing event. And I see there's a question here in the chat box. I'm going to attempt to address this. So numbers showed as CO2 in the supply chain. Are they international or US only? Is there a source on the numbers or just an estimation? So I actually worked with a customer. Unfortunately, I'm not quite at a place where I can share who this is with. But we did the carbon accounting of each one of the steps in the process. It bears noting this is an international supply chain with 14 discrete locations that we were examining. So when we think about the overall carbon impact, it's a component of it is when I manufacture the product, because conventional manufacturing does use a lot of energy and does produce a lot of waste. But you can see a majority of that carbon footprint is actually racked up in international flights. So one of the just sort of a spoiler here, but downstream, one of the things we're going to discuss is overall what are the choices we can make to reduce the amount of logistics, specifically things like international flights that rack up these humongous carbon footprints. So we'll go forward and talk a little bit about that as well. I see another question relating to this. In favor of moving to a digital footprint process, but what are the impacts of electricity use? Servers, routers, switches, computing power running 24/7. So a lot of people. So by the way, so I have if you're looking at the camera, and I'll stop sharing screen real fast so you can see the printers over both my left and right shoulder. So I have two of our printers. The one over my right shoulder being our top of the line industrial printer. The one over my left shoulder being a desktop printer. They both consume around 3.5 amps peak, which is like orders of magnitude lower than a CNC mill, which typically requires like 3-phase 208 volt power. So one of the first things that customers of ours that are doing mass production with our technology, one of the things they tell us is holy cow, our power bill went down by like 90%. So oftentimes when you look at the state of the state, there's when considering moving to a digital strategy, at the end of the day, digitization is great, but at the end of the day, it's got to make business sense. And that's actually one of the buckets of cost that we can influence in a really meaningful way by transitioning to a digital strategy. Another question, carbon footprint for the mining and processing of materials. So that's a great question. Apples to apples, the raw feedstock material is the same for 3D printing and a conventional process like CNC machining. However, the really neat thing about 3D printing is instead of starting with a block and machining that block down or carving it out into an end product, we end up being able to deposit material exactly where we need it. And in fact, we can take advantage of some design techniques like internal lattice structure to reduce the overall amount of material that goes into the product. So again, when thinking about both the environmental and the business impacts, the overall material consumption and in fact, waste byproduct is far lower. So while we still must take credit for the process of obtaining the material, because as the attendee who's asking this question has pointed out, that is a process that incurs a carbon impact. But apples to apples, the end product ends up having a far lower carbon footprint by comparison with a conventionally manufactured product. Okay, so I have one that I'm gonna have to admit I don't know, and if there's time, I'll do a little poking around at the end. But there's a question about the production of metallic powder on a tons of CO2 per kilogram. I'll again acknowledge that that's going to be apples to apples with typical metal powder, and I haven't talked a whole lot about what we do yet, but it bears mentioning that we make carbon fiber printers and metal printers. And the metal printers take a feedstock material that consists of metallic powder. I'm going to take a break from the questions here and get back to the presentation. I'm loving the questions, I'm loving the enthusiasm, and I'm loving the direction that this discussion is taking. So please, by all means, keep pumping them in. I just do want to make sure that we get to all the concepts, and I think some of the things that I'm going to mention in the presentation may answer some of the questions I'm seeing in the chat box. Okay, so we talked about this conventional supply chain, and really in the context of the event of an emergency where I'm trying to contain a manufacturing problem. And again, if you're in manufacturing, this is probably like a once or twice quarterly occurrence where I have that oh shoot moment where I have to go trigger one centralized manufacturing location to touch off on 14, 15, 100, 200, 800 distribution nodes. And that's really where conventional manufacturing has the largest opportunity to be transformed by digital strategy. Not only in terms of business continuity and business performance, but also in terms of the carbon impact. So when we do an apples to apples comparison of what this process would look like through a digital supply chain, which would entail a 3D printer existing at these discrete locations and producing the part at the point of need as opposed to shipping it, we're drastically reducing the overall carbon footprint of what that containment of that issue is going to cost us in terms of the overall carbon footprint. And it's really not just limited to these oh shoot manufacturing emergency moments. And we got to this a little bit in the Q&A, but I'll double down on the concept that we're using overall far less material. So again, it is an apples to apples in terms of the feedstock. However, we're using far less material to get you to your end product. And ultimately, that's going to have some downstream impacts in terms of logistics. So if you do choose to ship that part, it's going to be far lighter, incurring also a far lower carbon impact. And again, these printers consume less power than my microwave, which that's actually a poor example because microwaves are like 1400 watts. But in terms of how these printers impact my power bill, it's less than $10 a month. If that gives you an idea of how much energy they're producing, I'm running them lights out. So these lower power systems are driving an overall lower energy footprint, and it also bears mentioning the byproducts of conventional manufacturing like oils and lubricants are totally absent in this process. So far cleaner in terms of the energy usage and the cleanup. And as you'll note, I have two of these machines operating in my office, in my home. They take up very little space, and that space efficiency ends up corresponding to less land usage. So when we think about these vast manufacturing plants, it's our hope that in the future those plants could be more discrete, more self-contained, ultimately more automated, and save more land for repurposing for more carbon efficient means like reforestation. So Markforged, who are we? I've talked a lot about carbon impact and the environment and supply chains. Let's talk about Markforged for a moment here. So we're a company that was founded in Boston in 2013. The founding team came out of MIT. And the DNA of the company is kind of interesting because we're sort of equal parts mechanical manufacturing engineer and software engineer. And I don't want to put the cart too far before the horse here, but part of what unlocks the sort of digital component of what we do is our cloud-based infrastructure that I really have to applaud our CTO, David Benheim, who from day one built the infrastructure of the product with this sort of immediate digital distributed modality in mind. As a company, we have a couple superlatives, but we are leaders in terms of enterprise adoption and enablement. And I'll get into a little bit about what that means. And as a company, we were recognized by Deloitte as the second fastest growing hardware company in both 2018 and 2019. Fingers crossed we get recognized again for 2020, but jury's still out on that one. We've taken around $140 million from largely our last round consisted of strategic investors, including Microsoft, Siemens, Porsche, as well as Summit partners. And the cool part about, when I say we have a couple superlatives, this is probably the one that I would get tattooed on my chest if I had any tattoos. So we have the largest fleet of online industrial printers. And what that means is if you have a distribution node, there's a really significant chance we have a printer close to that distribution node. And all of the printers are online, meaning that when I encounter a problem or I encounter a part need, I can will those parts directly from the cloud to any one of the devices on the network, assuming that printer belongs to my network. So in the case of that supply chain emergency, a global parts manager can say, "Hey, I have this object that I need in Kuwait," and I can immediately digitally trigger that print to that location. So we're getting that part immediately. We're getting it all that inventory digitized, so we don't need to have storage racks ad nauseum in order to satisfy our customer demand, and we can keep it really organized. And the cool thing about Markforged as a company, and I'll talk a little bit about the solution scope in a moment here, but with all these printers connected to the cloud, we can deliver real-time improvements, which is on a weekly basis changing the total universe of parts that are technically addressable with the technology. Talking a little bit more about the solution scope here and why it matters in terms of these broader concepts like supply chain efficiency and carbon footprint. So when I think about what Markforged actually stands for and what Markforged means, it's really solving the most amount of problems in the box that's meant to go anywhere. And what that means is through our carbon fiber and our metal printing processes, we figured out a way to blend a really, really broad capability set that includes strength, accuracy, and quality to address a really broad range of applications. But we put it in a box where, to give a really concrete example, the bottom left corner here, this is a unit of the U.S. Marine Corps that's taken a fleet of our printers to a forward deployed combat zone in Kuwait, and is printing parts for mission critical maintenance and other operations where, going back to that supply chain slide, the only way to obtain those things would be through super linear and inefficient and ultimately high carbon, high fossil fuel consumption processes. And ultimately, they're winning as a result because they can get those parts immediately, as opposed to waiting in some cases up to 6 months to obtain the part they need. So I don't want to spend too much time going into detail about Markforged and our unique processes. I'd rather leave time for more questions at the end. But I do want to talk a little bit about the art of the possible, or the types of parts that people are producing on our equipment. You're seeing a lot of stuff here, so it's really not limited to those objects. But to name a couple things, the kind of things that our customers are printing are things like tools and fixtures, robot grippers, cutter bodies for mills, heat sinks in copper, CMM fixtures that are made out of high-strength carbon fiber, and a whole lot of end-use components that end up blending customization with end function. And when I talk, I mentioned a little bit about the concept of being able to send real-time updates to the devices. What that really means is when I think of the universe of parts that a manufacturer would need, we're constantly changing what that universe looks like. So in 2014, when we shipped our first printer, we were really looking at prototypes, a couple of low volume housings, some sensor mounts, and some work holding tools. As time went on, that picture started to evolve to include What I look at as a vast majority of low to mid volume parts that a manufacturer would want to produce. And as a function of that, we're solving more problems on a daily basis for our customers, which again, ultimately, to the topic of today's presentation, is reducing the carbon impact of the things and services that manufacturers produce today. So that concludes at high level what I wanted to discuss today. I see there's a ton of questions in the chat box here. We've answered the sort of pseudo answered the CO2 footprint of a kilogram of parts. So I'm going to go ahead and mark that as answered. Are the benefits also from metal 3D printing for spare parts of machinery in traditional manufacturing industries? The answer to that, so the question there is for when I think of a use case or a work stream that I'd call digital spares. So when instead of stocking my spare parts on a rack, I keep them in a library in the cloud and push print when I need them. The answer to that question is absolutely. The distinction being the metal process being multi-step. The way manufacturers typically do inventory planning is if it's a relatively fast-moving item where I might need a couple a week, they'll stock what they need for a week as opposed to stocking what they need for a day, and thereby reduce their overall inventory footprint. And then when you scale that out to a supply chain, a globally distributed supply chain, the same benefits are in play where I'm reducing the overall logistics footprint of what I need to do to solve manufacturing problems. Cool. So we've answered that one. We have a question, are your materials such as onyx recyclable? To be perfectly honest, our materials at this stage in the game are not recyclable, at least on the polymer side. I've heard of customers smelting down metal materials and reusing them for castings and things of the like. But this is actually one of the first questions I asked when I came to Markforged. Hey, why aren't we looking into recyclable spools? And really the answer is right now the best process I know of to recycle a filament would involve shipping those products back. And at this stage in the game, it does not appear that the benefits of recycling the material would overcome the supply chain impacts. And even so, there's examples of biodegradable filaments and filaments that have an incrementally decreased carbon impact. However, when to the point of if you remember that quadrant slide, I'll pull it back up. When we think of solving the most amount of problems for our manufacturers, it's our belief right now that our time is better spent increasing the total number of problems we solve. And then when that problem scope begins to include recyclable materials, I'm certain that's going to be something that Markforged investigates as a business. The distribution of feedstock is not the same as in more standard manufacturing. That's a great point. So as we grow as a business, when you look at all of these dots on a map, it's worth noting that we manufacture our materials in the United States today. So we must take credit for the reality that we need to ship the spools. The great part about that, however, is when we ship those spools, we generally do it in relatively high volume, and we can do it relatively slowly because manufacturers can stock material because it's universal to the type of part they want to print. So when I say 0.8 tons of carbon emissions, we're taking credit for both the production of the feedstock and the shipping of it. So that's where we sit today. You can imagine as Markforged grows as a business and we parallelize some manufacturing processes to get more manufacturing nodes in more places, as well as more warehouses, this whole picture is going to become more and more efficient over time. But thank you for that question. Oh, I see my good friend Alex has asked a question. Hey, Alex. in terms of the creation of waste when creating prototypes, how realistic is it to rework a part that has been carbon or metal printed? That's sort of a case by case thing in my opinion. So when I have a problem, like I made a hole too small, that's a pretty easy solve, right? I can just take it, put it on a drill press, and bore out that hole, no problem. So I don't have to go and redo that prototype. That said, I would say it's probably a similar picture to what you're currently experiencing with conventional processes, where if you're going to if a quick boring or tapping operation is going to fix your problem with a CNC mill, it's probably going to fix your problem with a 3D printed part as well. What our customers are telling us is what 3D printers unlock for them. And this is for a moment ignoring carbon footprint, but we'll add it back in a moment. In terms of speed and cost, I can make more prototypes, which on the surface sounds bad, but again, just harking back to the idea that this is a more efficient way of producing my part. To get to the finish line, which is a market-ready, market-tested version of my product, I'm overall incurring a smaller carbon footprint to get to ultimately what most of our customers are saying is a better product, because they have more bites at the apple as a function of more time and more budget spent on these 3D printed prototypes, by contrast with conventionally manufactured prototypes. Cool. Here we go. So this is a question about the energy consumption of the systems. So when I'm talking about reduced energy consumption, and I threw out 3.5 amps, that was specific to the composite printers, which do produce parts that play in the application space in metals. But again, we do offer a metal print system. That system does consume an incrementally larger amount of energy, but still about a fifth of what it takes to run a CNC mill, if that gives you a good idea. So kind of aside from cost and lead time, another factor to consider is energy consumption when choosing between composite and metal print systems. So ultimately it comes down, for our customer base, it comes down to what are the technical requirements in order to be successful. And if I need, the hardness, the strength of a casting, I'm going to go in the metal direction. If the stiffness of carbon is suitable for the application, that's generally the preferable route for a couple of reasons. Energy consumption being one of the major ones. Cool. Another energy consumption is this per unit volume. So on one hand, yes. So per, call it CC of form of material. I think about it a little bit on a broader scale, because I think about how we impact our customers' business in terms of number of problems solved, and that generally corresponds to a material consumption. But again, we're using less material in the process as well. So a wrench printed on a Markforged printer is going to be far less material than a wrench that's milled on a CNC mill. If that helps, happy to dive into some of the specifics in terms of energy consumption. This is kind of a tangential one, but I'll go ahead and address this. So not to undermine the benefits to the environment, but has the effect of advancing the technology affecting the job market, the negative effects, if any. So what this is actually doing, for at least in the United States, which is where I live, and Marielle mentioned at the top of the hour that my role at Markforged for the better part of the last 4 years was field based, where I would spend a bunch of time with mom and pop job shops, as well as humongous Fortune 500 companies and elements of the Department of Defense. What this is doing for the shop, the manufacturing floor, is really force multiplying what an individual factory worker, a CNC machinist, a tool and die maker, it's a force multiplier for what that individual can achieve on an hourly, daily, weekly, annual basis. So it's making those individual employees more valuable to manufacturers, and in fact, making more manufacturing opportunities addressable locally, which is both good for the job market as well as the environment. Do you guys work with extruders in addition to 3D printing materials? Yes, so it bears mentioning. So for those unfamiliar with Markforged, we make both. Well, we make three things. So we make the materials, so the carbon fiber and the metal feedstock material, along with some polymers as well for some lower grade applications. We make the equipment, so the two printers sitting over my shoulders, as well as a metal print system that I've alluded to. And then we make the software that, again, unlocks this sort of cloud manufacturing ecosystem. And so to the point of extruders, not certain if you're talking about like the actual material extrusion lines, but we actually have those in-house where we make our own feedstock material, and then the extruders that are native to the printers are also a component of our overall offering. Outlook for the size of metal printing. So today for our metal print systems, we generally say something the size and like roughly the footprint of a grapefruit is addressable. And I can get into the technical elements of what predicates that size boundary if it's interesting to you all. But really, I don't have a crystal ball per se, but I'll give you an idea of a trend. So when I started at Markforged, which was in 2017, our size limit was the size of a tennis ball. We say don't make anything bigger than a tennis ball on the metal printers, and again, it's grown to the size of a grapefruit. So while I don't have a crystal ball, what I will say is we have customers that are producing assemblies that consist of multiple constituent parts. That go to well over a meter in size, which was the question scope there. So, to give you an example, I'll pop off the video here for a second. So this component, this is a weight bench that I use at home. This was printed, believe it or not, on the print system that's directly behind me on my left shoulder. You say, hey, how'd you make that? And looking up closer, you can see what's really made of is a bunch of little woodworking joints that come together. We see the same strategy being employed with metal parts, but with the case of metal, you can actually be more deliberate in terms of designing it for welding these components together. And then we also see design strategies like hybrid. So many of our customers bring in both the composite print system and the metal print system, and the end part ends up becoming sort of an amalgam of the two, with the composite print system generally being better suited toward printing larger parts. Cool. Hopefully that answers that. This is an interesting one. So who owns the IP or the intellectual property of the part designs? So that's going to be, in my opinion, one of the most interesting topics of debate in the additive space over the next decade or so. On one hand, manufacturers have a vested interest in their customers being successful with their product. We see examples of take something like a weld shank, which is a component that's used in an automotive manufacturing plant in order to form bonds between chassis components. that's a specialty component that most automotive manufacturers source from outside, so they'll outsource that part. Um, but some of our customers are finding, hey, this is actually like a really technically appropriate component to be printed, and in fact, we're noticing some really significant design performance benefits as a result of printing this thing. Um, so the manufacturer of the weld shank, of course, would like to participate in that value chain. So what we're seeing now is these sort of supply chain configurations where a remote vendor will provide sort of call it the design spec or the instructions for the Markforged machine to print it. And then manufacturers can then download that part, send it to their printers, and either pay per use or pay per license. But I will say that's a really nascent value stream that's been very recently harnessed and unlocked by a small subset of our customers. Um, the more intriguing component of that is, with 3D scanners becoming more and more prevalent and higher quality, who's to say I can't scan a component that's made by an OEM and produce an exact replica? And that's going to be a topic of hot legal debate that will probably outlast me in this industry. So thank you for that question. Definitely really intriguing concept there. Follow on to that, why are the materials so costly? So again, I'll acknowledge that the process by which we make the materials and obtain the materials is sort of like for like with conventional processes. When you think about something like CNC machining 100,000 components, economies of scale begin to catch up relative to additive manufacturing. So in the case of a one-off jig or a fixture, a printed component is generally, as a rule of thumb, about 10 times cheaper to produce. But if you're comparing something to, if you're comparing a printed component for something like a connector that goes on an iPhone, where I make millions of them per month, that's probably an application space where economies of scale are going to predicate a preference for conventional manufacturing techniques. Also, follow-on question about design software. So for most 3D printing systems, Markforged included, we generally take exported CAD files in the form of what's called an STL file, which is sort of like a face tessellated solid model of what you intended to produce, and it ends up being a really, really high fidelity version of the model, assuming you export with the right settings. Question about the impact of shipping material around the world versus shipping parts. So that was something we talked about a little earlier, but just to double down on sort of how we think about the digital supply chain. When I have a spool of material, that spool you can think of that as sort of a generalized form of what's going to become a bunch of different parts. And as a logistical shipping unit, a spool, or what in majority of cases is a bundle of a bunch of spools, is a far more efficient way to transfer what I would think of as manufacturing potential density, or my ability from one box to get lots of parts. If that's helpful, let me know if that's worth getting into more. Sort of a comment here about carbon footprint of warehouses. That's candidly not something I've spent a whole ton of time researching in terms of. I made a little bit of a comment there about space utilization and the carbon impact of transitioning to a process that takes up less space. I can qualitatively tell you that that's better for the environment, but I can't exactly quantify that at this moment. But hit me up on LinkedIn and we can have a discussion about that. A good question. So DX7 printer, is it capable of printing two materials simultaneously? I'll get my my bag of tricks out here. So this is a wrench that's made of a couple of constituent components. So the black material you're seeing there is a thermoplastic polymer, which you can sort of think of as a low impact base to the material, and then the interior structure of it, or you can almost think of it like the skeleton, is printed in continuous Kevlar. So I didn't spend a whole lot of time talking about the Markforged solution set today, but we're known in the industry for inventing what's called a continuous fiber process, where we'll lay down a layer of plastic material, and then we'll fuse in a continuous fiber into that part. And it ends up being a really low cost and efficient way to produce parts that, again, start to address some of the application space that used to be reserved for metal. Cool. Someone's asking, is there a way I can understand the cost benefit of adopting 3D printing for my business more than just the environmental impacts? What I'll say to that is oftentimes the things that make sense for the environment end up making a lot of business sense. Actually, a mentor of mine once told me that, a business owner out here in California. But if you wanted to spend a little bit more time understanding whether this makes financial sense, you're saying, hey, Daniel, I believe you, this is great for the environment, but my boss isn't going to go for it unless it saves us money. What I would recommend is going to our website, and I'll actually do a quick demo and a plug for this here. And apologize if this is like a little bit too self-promotional here in the context of what's meant to be a presentation on environmental impacts, but I think this is probably worth taking a peek at, if you're feeling like you're close to arriving at a business case for additive manufacturing. So I could go to it's markforged.com/ROI calculator. You can find it in the resources tab of our website. I can say what industry I'm in, and then it'll reveal a couple options in terms of what I want to make. So say I'm making tools and fixtures. We have a number of different sort of reference applications you can take a look at. If your application doesn't quite match up, don't worry too much about it. You can look at parts that fit the relative size of it. We'll give you a little bit of help in terms of what the right material for your application would be. In this case, we'll stick with composites. And I just need to say how many per year I need, and what my current unit cost is $750, say it's $700. And then we'll get report. And now I have a nice little report in terms of the cost benefit of producing these parts with Markforged. And we'll tell you what kind of equipment you need, what your annual spend is going to look like on the basis of the unit quantity you told us you need, and how this investment is going to pay for itself, and how long that payback period is going to take, along with the lifetime business value. So understanding full well that's not a silver bullet for every business case. That would be my recommendation as a first stop. And then we have an amazing both channel and go-to-market sales team that can help you sort of further solidify some of those concrete and sometimes a little bit intangible business outcomes that we see our customers achieving with additive manufacturing. Cool. Kind of covered this earlier, but someone's asking about the raft material or some of the byproduct material that comes out of the metal process that doesn't end up getting used in the end part. We do actually see customers smelting that material down. So we print with some really common steel alloys on the metal process. So for customers that already have a foundry on site, we're seeing that being a fairly common use case. And hey, if you don't have one on site, call one in town and see if they can use it. I think that would be a wonderful use for our byproduct which it bears mentioning, while we do purvey a system that overall has less waste, there are a couple byproducts that end up being utilized to ensure that the quality of the part is in spec and addressable for manufacturing applications. Another question about materials and sort of what the next few years look like for us. While I don't have anything super specific to share at this point in time, I would think about Markforged and our posture toward new material and new equipment development as ruthlessly and relentlessly prioritizing the things that are going to increase the amount of problems that you as manufacturers can solve on the factory floor. So while that's a really non-specific answer, at the very least, with that full context, perhaps if you have a Markforged representative you're in touch with, you can tell them what materials are most applicable to the kind of things that you would like to produce that aren't already in the wagon. Good question from Carolina. What would you recommend as a change management strategy to commit production engineering to transition? I take it that's a question coming from a relatively large organization where that inertia of conventional manufacturing processes is very real, especially in large companies. And I find there's a couple really good strategies. One of which is find one home run application, and then oftentimes what we see is fairly organically that one application ends up sort of making the rounds across engineering, management, and production, and sort of, for lack of a better term, infects the organization with a new dogma that producing these parts additively is a more efficient and better way to make my product. Beyond that, we actually offer an enablement program called Markforged University, where we've seen huge organizations like the Department of Defense, big Fortune 500 companies indoctrinate everyone from their production staff, engineering, and even the accounting team on how additive manufacturing can transform your business and sort of how to design for the process, how to implement it well. So if you feel like you have sort of like an addressable opportunity that requires that incremental level of enablement, I'd highly encourage you to take a look at Markforged University as an avenue toward enabling the team. And we're getting to the top of the hour here, and I see I have far more questions than I'll be able to address in the next 10 seconds here. So I really appreciate the participation in the chat box. Can't tell you how much fun that makes it for me. And I really appreciate y'all joining me today and participating in this discussion that I'll reiterate, I think is one of the most important problems we can solve as an industry today. So as a follow-up, what we'll do is we'll provide a recording of this presentation. So you can either rewatch or share it with the rest of your coworkers, friends, family, whoever. And then we'll also make an attempt to address, where possible, some of the questions that came up in the chat box that we weren't able to get to today. So thanks again. Mario, anything else? I'll leave it to you to close up shop here.
Awesome. Thank you so much. So as Daniel said, there will be a recording of this webinar sent around later this week to everybody of the on-demand asset. Feel free to rewatch or to share. We will try to do something to address all of the remaining questions also post-webinar, so keep an eye out for that. Thank you so much for joining, everyone, and have a great day.